Alrighty. What are we doing today? We're continuing the free energy principle stuff. I mean, I think I started. No, I started two things. So I started basically uh knowledge tomography. I started knowledge tomography. Um, I started knowledge tomography, and I'm now thinking whether I should. So I started knowledge tomography, which I wanted to continue, and I was using yesterday to explain some of the stuff around the harness. And I'm thinking to actually do start another one of the free energy principle. I have one on torque. These kind of stuff is for the for the public spaces. It's all good. I'm gonna create a new space workspace. I'm gonna new space from blank, and I will start with the free energy principle. So I'm gonna do a free energy principle one, and then I'll see if I can connect workspaces. I wanna get to a point where because I feel I'm gonna get there where workspaces kind of can be connected. You can go from one place to another. Kind of makes sense in a way. But I want to start here by doing free energy principle, and I just want to start like. And I like starting with this shape. It seems to work very well for a few reasons. It's just one I like working with a lot. And we'll start creating these blocks and see what we get. Okay, so we'll start with these, and we'll start small. I'm not going to explore them. I'm not going to build the map out too much. I want to actually start exploring these. And again, I'm fine tuning the exploration interface still a lot. I'm like it's still likely you know gonna be a little buggy, but essentially that is this cross is what I care about. The other topics will likely just put aside for now, and I'm gonna focus on this cross first. But I wanted to have these other topics already laid out for me, because I know they're going to become relevant. It almost feels like that's kind of like a starting move that I noticed I do a lot. I kind of like start with a cross, um, and then I look at the sort of outer edges, and usually these one like the outer cross edges or the outer cross vertices actually end up forming a group in and of itself, and the square edges here end up forming another one as well. It's kind of like I find it an interesting pattern, I guess, of how these topics are created. And I shouldn't have created all of them as starting blocks, to be honest. But anyway, but we have these are we've got active inference, we've got Markov blankets, variational free energy, precision weighting. These I'm less familiar with, but I've heard these a lot. Um, but we'll start with the foundations as soon as this block is ready to go. Yeah. And I can publish this workspace if people want to then fork it or whatnot. Um, these planning as inference, I think these things are definitely a bit more further away topics. I should have just maybe done the square initially. Okay, we've got this here. So before I do anything here, I'm not interested in any of these right now. This is more for like authoring workspaces for other people. Oh, I still have that back. Block simulation auto triggers. What? Sorry. Block simulation should not auto trigger. This is definitely a bug. I just wanna get a feel of what I'm getting here before I start in play mode. So I'm just taking notes as I go because I know those things are get auto added. value, and that's perception updating the prediction towards, so that's perception updating 10, or action changing the world towards 4, both count as free energy minimization and the free energy principle. I think so, but I think these are interesting starting questions. Yeah. In the foundational FEP picture, sensory states and active states form the interface between internal and external states. If that interface is a Markov blanket, which conditional independencies must hold so that internal states only see the outside through sensation. Okay, that's maybe a bit more on Markov blankets, which I would expect to see here, but it's kind of okay, I think. Name the kite signal the system is failing to self-evidence internal states, drift. Name the catch signal. Name the catch signal that the system is failing to self-evidence internal states, drift. Attracting set of phenotypic states. There's a lot of vocabulary that I need to break down, but it's good. Okay, and then we've got more advanced exercises, but the exercises are, I'll leave them for drilling sessions. First, I'm gonna just do an explore with AI. I'm thinking an explore solo makes a lot of sense as well, because it's a little more open-ended initially, although the AI one is quite guided. I'll do with AI. Let's see then. You know, that starts here. We're gonna go with Greco-futurism, and I'm gonna start balanced. I just like balanced always. I'm gonna just likely have Grok active anyway to get stuff. All right, so let me get started. Cool. So we are here, frame free energy minimization as so we're in this chapter, frame free energy minimization as a candidate unifying principle for perception and action. What must the system keep low, and why does that sound like Bayesian inference? So we have to start framing free energy minimization as a candidate unifying principle for perception and action. Okay, so it's a candidate. So we're looking at, let's see how do we phrase these, right? How do we break this down? So we need to frame. That's what we need to do. Free energy minimization as a candidate unifying principle of perception and action. So let's look at perception and action. I'm just gonna give me some principles of perception and action as examples. I'm learning about free energy principle, free energy principle, but give me a broader perspective if possible. I just want to again, and you can see that I'm having here the little picture over picture, right, from the system. So we're now basically structuring this thought here. We're not kind of like trying to answer this question, okay? And note here that, so there's, and this is maybe a bit of a meta comment, right? But note that there's a structural difference between me having to take that action explicitly here, of taking this question and going out somewhere to find the answer, than me reading through a generated text or a context where the information is laid out for me and I'm supposed to just read it and understand it, right? I'm doing active inference I'm doing like an active inference type of action here, active questioning, which is actually what makes it very what makes it effective as well. Let's see if these guys are. So let's look at principles of perception and action. Starting from the free energy principle, active inference, you're starting, then widening to lens of classical, ecological, and inactive views. Under the free energy principle, a system that remains far from thermodynamic equilibrium must minimize variation of free energy. Roughly, long-term surprise or prediction error. Perception does this by updating an internal generative model so that its predictions better match incoming sensor data, and action does so by changing the world or the way it is sampled so that sensory data better match the model. So this is FEP. I mean, I knew this, perception and action. Now, broader principles and conscious inference helps more. So these are other principles. And conscious inference, perception is rapid, automatic inference at the most likely cause of sensor signals guided by prior knowledge. So it's just a definition. From the slight disparity between two retinal images, the visual system instantly concludes depth. You know, prediction error, free energy minimization, predictive processing, FEP. Updates beliefs to reduce mismatch. Affordance perception. We primarily perceive action possibilities relative to our body and capabilities, not abstract object properties. Towards perception is already, I mean, this is interesting. Perception is already oriented towards action. A staircase is seen as climbable or not according to rise or height relative to your leg length. Mastery of sensory motor contingencies. The qualitative character of experiences arises from knowing the lawful ways sensory signals change with movement. Perception is a form of skilled exploration. Interesting. The feel of redness or of a surface texture's knowing photoreceptor or tactile activity will change if you move closer. Tilt your head or run a finger across it. Skilled exploration. This is interesting. I guess that means, skilled exploration in this case probably means just action. Reafference. The system predicts the sensory consequences of its own movement so it can cancel them and detect external change. Interesting as well. Why you cannot tickle yourself. Can I tickle myself? Ideomotor. Actions are represented and selected via the sensory effects they produce. Active sensing do not passively receive information. They move to sample it optimally and reduce uncertainty about hidden causes. But I mean, this is again reducing uncertainty. Heavy predictive accounts, Halsman's representation heavy predictive accounts, and emphasize internal alternative models and inference and a more relation to body environment accounts. Yeah, that's true. I mean, I like these ones. I think they are interesting because they kind of like a bit touch upon the fact that we are not like isolated observers of the world, right? Like we perceive the world biased towards how we can act on it, right? Which kind of makes sense, but I guess for the purposes, I guess there's a different models that might serve different purposes as well, right? So that's kind of like okay, maybe I should actually just explain this a little better here. What's happening here? Maybe I should put this a bit bigger, and it's okay. It's okay. Let's go back here, and I can close this now. Can I close this if I'm here? I should be able to close it, right? Yeah, okay, cool. So free energy minimization as a candidate unifying principle for perception action. What must the system keep low? And okay, I think I can explain that. So you know what is not clear though? I now just realized it's not clear that I actually have to press enter to do that. That's definitely not clear actually. That sucks pretty much a lot. That's an important piece of these. Okay, let me to frame free energy minimization as a candidate unifying principle for perception and action. What we can do is basically take a look at those definitions from the free energy principle perspective, which is that perception and action both have as an outcome that they reduce the amount of surprise in how we understand the world. Perception basically adapts our own internal model. Action adapts the external model, or like, you know what I mean? Um, that sounds like Bayesian inference because in Bayesian modeling and Bayesian inference, like in Bayesian models, what you're doing is you're constantly updating your prior based on observations. That's why it sounds like that, because you're updating you can update your generative model of the world. Okay, this is a problem. I see now this is a problem because now I actually have to go through here. I cannot. I would want to send these. It just auto stashed it, which is stupid, and it's keeping these three, which are basically the first three. This is actually a big bug. Sorry guys, I'll have to stop here because that's actually a bit of a blocker. As I said, this is still pretty buggy. And I just want to make sure the usability of these is actually very key, because this is a very dense interface. So the stashes don't move. The stashes are the alt stashes. I need a better way. Submit in ILE. A quicker way to do this. Compose thoughts, because they'll be naturally auto stashing displays them naturally. Sorry, this is actually not related to the matter here, but I mean, I'm gonna basically let me try to summarize this, okay, so that we can actually just send it and then call it a day for now. We want to frame free energy minimization as a finding principle, as a sort of like unifying principle for perception and action, because what we're doing is your perception and action both change the surprise of your observations relative to our internal model, and that's what you want to minimize, that surprise. And this sounds like Bayesian because you're updating priors. I had to try to keep it condensed because I didn't want to split it. That's kind of like a bug right now. So, and I wanted to at least submit these, and now at least I'm getting sort of like to the next. Surprise is a bit about the observations, not the priors themselves. Yeah, priors shape the model, updating them. Be a tiny example. Okay, so we can actually, yeah, it kind of guides me through this. That's all good. Okay, cool, perfect. I need to improve these. I need to improve the submission because it's just very cluttered here. Anyway, let me go back to the workspace for now. We'll keep it there. It's all safe. See you guys tomorrow.